This is 30 degrees. Okay, you have to find out the tension in all the ropes. These are some joints, sir. These are some joints. Can you apply Lamis theorem? So at the junction one, you can't apply because here you look at this one, 1, 2, 3, 4. 4 ropes are there here. Here 3 ropes are there. At block A, you can't apply Lamis theorem because Lamis theorem applicable only for when there are 3 forces are there. So what is the best thing? Take help of the resultant forces acting along X along Y. So let's give the name for the difference. So tension here, let it be T1, here T2, here T3. So call this is TA, no problem, like this. And this is MAG. This tension T3, call this is T4, and let this be TB. Equating forces along X, along Y, and solving them will get the required answer. So I think easily you can proceed from here. So here, this angle will be 45. So this angle is what? 37. Along x-axis, T3 cos sine 37 should be equal to T4 sine 45 along x-axis. So this is a junction A, you write it, junction B. So we'll begin with at junction B. At junction B, net force along x-axis on system should be 0. So T3 times sine 37 minus T4 sine 45 should be equal to 0. So T3 should be equal to sine 37, 3 by 5 by root 2. So T3 is equal to 5 T4 by 3 root 2. Keep it equation 1. Along y-axis, T3 cos 37 plus T4 cos 45 minus MBG equal to 0. What is the mass of the block? 40 Newton it will become. So T3 cos 37, 4 by 5, T4 by root 2 equal to 40 Newton. I think solving 192, I'll get T3 and T4. Okay, fine. Solving 192, I'll get T3 and T4. You work out later on. Huh? Just let me discuss the idea. Come for here at junction A. Again, you apply it. At junction B, you can apply Lamis theorem. You'll get the same answer. Junction A, you should not apply Lamis theorem. There are more than 3 forces are there. So what is the best thing is resolving the forces along X, along Y. So T2 is equal to, this will be 30 degrees. So T2 cos 30 should balance TA minus T3 cos 37. And what is TA is equal to? TA minus mg equal to 0. So we'll get the value of TA. TA is how much? 20 Newton. Equal to 0 U. Then along x-axis. Along x-axis, this is net force. Along y-axis here. Along x-axis, T1 minus T2 sine 30 minus T3 sine 37. I think we know value of T3, that you substitute, you know T, you'll get T2. Similarly, T3 value, you know, from this equation 1 and 2, substitute here, and you know T2 from this, so we'll get the T1. So there's a one number of ropes are there, no? There's a basic condition for equilibrium.
Sir,
Yeah.
sir, at junction A, sigma Fy is 0, T2 cos 30 plus Tm, sir.
T2 cos 30. Yeah.
Plus TA.
Oh, I
It should
think
be plus.
tension will act away from the body, no? The TA is what I shown on the. Okay, fine now.
Yes, sir. Yes.
Tension should always act away from the body. Okay, that one. You are confusing with the arrow. Okay, no?
Okay, sir.